I am your presenter, Edward Asante Ekofo. In this lesson, we'll be focusing on measurement of volume and other physical quantities. Can you think of substances that have no volume? All matter has volume. Air has volume, as well as the table and the chair. What then is the volume of an object? At the end of this lesson, you will be able to 1. Define volume and state the SI unit and the subunits of volume. 2. Identify the apparatus used to measure the volume of substances. 3. Determine the volume of irregular and regular objects. 4. Identify the measuring instrument of time, temperature, and current. We start with volume of substance. The volume of a substance is the amount of space occupied by the substance. All solids, liquids, and gases have volume because they take up space. For example, volume of diesel delivered by a pump to a truck. Volume of water in a polytank or a water reservoir. Volume of LPG in a gas cylinder. Now let's look at the unit of volume. The standard SI unit of volume is the space occupied by a cube that is 1 meter along its edge. It is described as cubic meter and denoted as meter raised to the power 3, or what you call meter cube. The other subunits of volume are the liter, which is a non-SI unit of volume, commonly used for volume of liquids and gases and denoted by small l. The liter is the volume of a cube that is 10 centimeters along its edge. The milliliter, denoted as ml, is the non-SI unit of volume, which is 1,000th of a liter. The cubic decimeter, denoted as dm cube, is the volume of a cube that is 1 decimeter along its edge. The cubic centimeter, denoted as cm cube, is a unit of volume that is 1,000th of a cubic decimeter. The table shows the relationship that exists among various units of volume. The table is about units of volume. It has 4 columns. We have units, we have symbol, we have relationship with the SI base unit, and we have other relationship. The first one is cubic decimeter with a symbol of dm cube. Its relationship is 1,000 cubic decimeter is equal to 1 cubic meter. Other relationships, we have 1 cubic decimeter is equal to 1 liter. We also have 1 cubic decimeter is equal to 1,000 cubic centimeter. We also have cubic centimeter with a symbol cm cube. 1 million cubic centimeter is equal to 1 cubic meter. For other relationship, we have 1 cubic centimeter is equal to 1 milliliter. We also have 1,000 cubic centimeter is equal to 1 cubic decimeter. The next unit is cubic meter with a symbol m cube. 1 cubic meter is the relationship with the SI base unit. In other relations, we have 1 million cubic centimeter. And finally, we have milliliter with a symbol ml. Relation with SI base unit is 1 million milliliter is equal to 1 cubic meter. For other relationship, we have 1 milliliter is equal to 1 cubic centimeter, whilst 1,000 milliliter is also equal to 1 cubic decimeter. Now we move on to interconversion of units of volume. With the first example, the volume of humus applied to a tomato plant is 0.95 cubic centimeter. What is its volume in cubic meter? Now for the solution, let's list the known and the unknown. For known, we know that the volume of humus is in cubic centimeter and it is 0.95. But for the volume in cubic meter is what we are after, which we don't know. Let's use the relationship between cubic centimeter and cubic meter to find the solution to the problem. 1 million cubic centimeter is equal to 1 cubic meter. Then by simple ratio, 1 million cubic centimeter is equal to 1 cubic meter. Therefore, 0.95 cubic centimeter will be equal to 1 cubic meter multiplied by 0.95 cubic centimeter, or divided by a million cubic centimeter. And this will be equal to 9.5 times 10 raised to the power negative 7 cubic meter. Do you understand it? Okay, let's take the second question. The volume of helium gas used to fill a balloon is 500 cubic centimeter. What is its volume in cubic decimeter? Let's take the known and the unknown. We know the volume of helium gas in cubic centimeter to be equal to 500. But the volume of gas in cubic decimeter is what we are after, which we don't know. Now let's use the relationship between cubic centimeter and cubic decimeter to solve this problem. 1,000 cubic centimeter is equal to 1 cubic decimeter. Therefore, 500 cubic centimeter will be equal to 1 cubic decimeter multiplied by 500 cubic centimeter, or divided by 1,000 cubic centimeter. And this will be equal to 0.50 cubic decimeter. Is this answer very clear to you? Now let's move on to volume of solid objects. The volume of regular solids are measured by using the dimensions of the object and a formula. For example, a cuboid. The volume of a cuboid is length multiplied by the breadth multiplied by the height. Problem number 3, or question 3.
The dimension of a cube
was measured as length is equal to 10 meters, breadth is equal to 10 meters, and height is equal to 10 meters.
What is the volume of the cube?
To solve this problem, let's start by listing the known and the unknown variables. For the known variable, we have length to be equal to 10 meters, breadth to be equal to 10 meters, and height to be equal to 10 meters. For the unknown variable, we have volume in cubic meter. We'll use the known and the unknown variables and the formula for finding volume to solve this problem. The formula for finding volume is V is equal to length times breadth times height. So we now substitute the figures we have under the known variables into the formula. And we have 10 meters multiplied by 10 meters multiplied by 10 meters. And this is equal to 1,000 cubic meter. I believe you agree with me with the answer. Now let's move on to measuring instruments for volume of liquid. The common apparatus used to measure the volume of liquid in the laboratory are measuring cylinders, beakers, pipettes, conical flask, burettes, volumetric flask. The choice of an apparatus depends on the type of experiment being conducted and the degree of accuracy of the results. Now for the first one, we have measuring cylinder. This instrument is used to measure rough volumes of liquid samples. It has different capacities. We have 5 ml, we have 10 ml, we have 25 ml, we have 50 ml, we have 250 ml, we have 500 ml, and 1 liter. When using the measuring cylinder, use one having volume close to the volume being measured. For example, use 5 ml measuring cylinder to measure a sample of volume 3 ml. Now we move to pipette. It is used to measure specific volume of liquid accurately. It is also used in titration process. Now I move on to beaker. It is used to hold and measure rough liquid volumes. It has different capacities. We have 5 ml, 10 ml, 50 ml, 250 ml, and 500 ml. Another instrument used is the conical flask. It is used to hold and measure rough liquid volumes. It has different capacities. We have 5 ml, 10 ml, 50 ml, 250 ml, and 500 ml. We also have burette. This instrument is used to measure accurate volume of liquids. It is also used to perform titrations. We have the volumetric flux as one of the instruments here. It is used to measure specific volume of liquid accurately. It is also used to prepare standard solutions. A standard solution is a solution whose concentration is accurately known. We now move on to measuring volume of irregular solids. The volume of solids without regular dimensions are determined by the displacement method. To conduct this activity, we need the following items. We have a beaker with water, we have a measuring cylinder, and we have the irregular solid, which is the stone, tied with a thread or a string. Now let's start with the procedure. We're supposed to fill the measuring cylinder partly with water. Then record the volume as V1. So for what I have here, it is 94. Then tie the irregular solid with a string or thread and lower it into the partly filled measuring cylinder. So as you can see, I have already tied the stone with the string, and you're supposed to lower it gently into the measuring cylinder. After that, record the new volume as V2. And what I have here is 104. The volume of the water displaced by the irregular solid is equal to the volume of the irregular solid. Therefore, the volume of the irregular solid will be equal to V2 minus V1. Now at this point, let us substitute the figures into the equation. So we have V2, which is equal to 104 cubic centimeter minus V1, which is 94 cubic centimeter. And this will give us a final answer of 10 cubic centimeter. This answer represents the volume of the stone that was immersed in the water. Now let's move on to precautions to be taken when using these apparatus. Do not use these glass apparatus to measure the volume of hot liquids to avoid expansion. What we're saying is that if you have a liquid which is hot, that you want to measure its volume, do not use glass material. Remove air bubbles when using burette or pipette. Reading of these measuring instruments should be done with the eye level coinciding with the lower part of the meniscus. And the meniscus is the curved surface of the liquid. So you bring your eye to the level of the meniscus so that you are sure what you're measuring is precise, accurate. Wash both the burette and pipette and rinse with soapy water, then several times with distilled water, and then with a solution to be contained. Well, students, at this point, I will entreat you to join me back in the classroom as we continue the lesson. Other measuring instruments. Several other instruments are used in measuring various quantities. Stop clock or the stopwatch. These instruments are used to measure time of an event. Then we have thermometer, which is used to measure the temperature of a substance. An ammeter is used to measure electric current. A voltmeter is used to measure the voltage of a cell. A hydrometer is used to measure the density of liquids. Now let's recap what we've done for today. The amount of space occupied by matter is the volume of that matter. There are several units of measuring volume of a substance. The SI unit of volume is the cubic meter. The volume of regular solids are measured by using formulae. Volume of liquid sample is measured using apparatus such as measuring cylinder, burette, pipette, beaker, a volumetric flux, etc. Volume of irregular solid is measured by displacement method. All too soon, our time is up. Now I believe you continue to read, think, and research about science before I see you some other time. Have a nice day. See you.